multiplying and dividing rational functions is very similar to factoring and simplifying them, because actually we can use the exact same strategy. But before we get into rational functions, I wanted to review, well, what about the rules for basic fractions? Because again, it's pretty much the same idea. So let's say I had the fraction, let's just say we're going to do 4/5 times 7/10. The rule for multiplying fractions, actually, let me make it so it's not reduced. But if it, like, let's say our fractions weren't reduced from the first part, the first thing you want to do is simplify each fraction individually before doing anything else. Actually, let me change up the number. Let me change up the numbers a little bit. But let's say we were multiplying by 10/7 or whatever, because I want to draw some parallels to rational functions. In this case, neither one of those can be simplified, but that's something you could consider first. Could either fraction be simplified? And once they are, once we say, okay, no, they're not simplified, the rule for multiplying fractions is they will multiply straight across. And if you ever wondered why this is the case, because a lot of times when we learn this in elementary school or whenever, our teacher, we don't ever necessarily understand the reasoning behind this, but I don't want to get into it in this video. What we'd end up with is 40 divided by 35. And after multiplying, we could then simplify by a factor of 5, which would reduce down to 8/7. But the gist of it is we can multiply across. However, if we were to first factor those numbers, we can actually skip a step. And that's kind of like our usual plan of attack for multiplying rational expressions, is that, right off the bat, notice that sorry, my pen's not working, is that 5 and 10 share a common factor. I could rewrite 10 as 5 times 2, and I could cross cancel factors like that. Now, I wanted to reiterate, this rule of cross canceling is always allowed, because what will end up happening is we're just going to multiply them all together anyway. So after multiplying, there will be a simplification by the common factor. And basically, the cross cancel rule gets me the same answer. And we often will use that as a shortcut with a rational function. But I wanted to reiterate, cross-canceling like this only works for multiplying. It does not work for adding, subtracting, or dividing. So I take each of these tricks and shortcuts that you see with a grain of salt, because it's very easy to use them in the wrong circumstance. And that's way worse, because, I'd rather you just do them the long way if you're not really sure it will cancel, because that way we won't make algebraic mistakes. So let's do a couple examples. Looking at the first one over here, it says x squared minus 25 divided by x squared. And really, if you didn't know any better, you could just totally multiply, because how multiplication works. I could multiply that times that, and this times this, because that's what will happen. But basically, usually in your homework problems, we don't want to do that, because there's usually a shortcut. There's a much simpler way of approaching it. And really, again, if you look at my step-by-step things, what it says to first do is factor everything completely, both the numerator and denominator. Basically, we're then going to multiply them all together, cancel any common factors if they exist, or again, you can cross-cancel, as I was saying before. And often we just want to leave the answer in factored form. So basically, like in this one, I could factor basically all 4 of those polynomials. The first one is a difference of squares. That would be x plus 5 times x minus 5. The one on the bottom would be x plus 5 times x plus 2. Then looking at the secondary rational function, the numerator has a common factor of 7, and the denominator is only x minus 5. And I could write that in parentheses, because ultimately those two are just going to jam together into one bigger one, because that's how multiplication works. Top times top, bottom times bottom, and what we're going to get is just a big long string of factorized polynomials on the top and the bottom. But also, since these are all just going to multiply together anyways, afterwards we're going to have some common factors, and that's the reason we're allowed to cross cancel. Like in this case, the x minus 5 is going to be a common factor in the end result. And the x plus 5, we could have simplified that to begin with from the first rational function. And also, x plus 2 is common. We could cross cancel that as well. So at the end of the day, I'm going to be left with 7 on the top. And remember, when something completely cancels on the bottom, that does not leave you with 0, because when a chain of multiplication is gone, you're always going to be left with 1. So what I would get is 7/1, or just 7 after all is said and done. And essentially, that is my answer here. This big, horrible mess of a thing is all going to simplify down to 7. And that's kind of the point of simplifying is, we could take some big, complex expression of polynomials, and it all boils down to a common number. And this is kind of interesting. You can try this if you want. You can plug in any x value you want into this horrible, horrible thing, and what you'll see is no matter what you plug in, you're going to wind up with 7. Well, except for the case when the denominator is 0. Technically, there are still those 3 undefined values, as I said in the last one, because you can't divide by 0. Now, moving on to dividing. Dividing is very much the same idea. Let's say I had 4/5 divided by 10/7 instead. Well, the rule for dividing fractions is, we often call it the flip and multiply rule, where I could change division by a fraction into multiplication, where I keep the first one the same, and I flip and multiply into the secondary fraction. And again, I don't want to get into why this rule is true because it's quite a complex rule, but from there, now it's just the same exact type of problem. I would multiply across, and here I would get 28 over 50, and then reduce if I can. In this case, I can't reduce those, so I will leave it be. But let's do an example of dividing two rational functions, because it's very much the same idea. You want to still first factor everything as much as you possibly can, flip and multiply, and then cancel anything in common if there is anything. Like with this one, there was nothing in common, so I did not do any canceling. But if there is, it will make my life easier. So the first one will, and maybe it's smart to flip and multiply first, but I'm just going to skip that step. But what I'm kind of imagining in my head is this will change to multiply, and these two will flip positions because that is how division works when I'm dividing by a fraction. So the first one would factor as 2 times m plus 7. 5m squared will not factor. Well, it's just a single term. Technically, you could factor as 5 times m, but that's silly. Now, the second one I could, again, flip and multiply. The denominator would become the new numerator, and that has a common factor of 5, which would leave me with m plus 7. And the original numerator, which will now be on the bottom, has a common factor of 2m. And that would leave me with 3m plus 1. And in this case, again, now that everything has been flipped and factored, I could look for common factors. And actually, you might notice the m plus 7 on here, but this is where an easy mistake, because notice that m plus 7 is a common factor here and here, but they will not cancel because both of those m plus 7s will be in the numerator. So cross-canceling only works if one is on top and one is on bottom. Here, they will not cancel. But what will cancel is, notice there's technically a common factor of 5 and a common factor of 2, because those would both multiply out to make 10 if I were just to multiply all that crap together. And since 10 is a common factor on top and bottom, those will cancel. And in this case, what that would leave me with is, well, m plus 7 squared on the top, and then m squared times 3m plus 1 on the bottom. And again, we could multiply all that out if we wanted, but usually we want to leave our answers in a factored form. But multiplying it out would be totally fine as well. That would leave me with m squared plus 14m plus 49. And in the denominator, by distributive property, I have 3m cubed plus m squared. And, I don't care how you answer it on a test, but pay attention to the instructions on your homework. Sometimes, whoops, you can't see that. But sometimes it might ask for it in either form. Usually it will accept it in factored form, and that's usually easier when it comes to rational functions because having the factored form is better for most circumstances.